Okay, we are moving into the last lesson of chapter 4. What a meaty chapter. I've been doing this since like the end of November.
It's been depressing.
All right, warm-up problem. Use a calculator to approximate the measure of angle A, and it says to round to the nearest tenth of degree. Anybody want to walk us through how you solved this?
Can I do it?
Yes.
Did you do it yourself?
Tell me what to do.
Yeah.
Tell me what to do.
What I did was I put in my calculator second cosine, so I got the cosine, the inverse cosine.
Good.
And I put in 7 divided by 12.
Awesome. Okay. The only other thing I'd maybe like show my steps here. So Jackson knew that the cosine of angle A, right here, is adjacent over hypotenuse. Beautiful. So to find the actual angle, that's what we use inverse. And again, because we're in a right triangle, please make sure you're in degree mode. And it says to the nearest tenth of a degree. Okay, Jackson, what did you get for an answer?
54.3 degrees.
Me too.
Makes a lot more sense.
54.3 degrees. So, folks, anytime you're trying to find the angle, we're thinking inverse. Okay, so because we hadn't got into inverse function yet, all of the right triangle application problems I've given to you, you've just been solving sides. Now I'm going to throw in ones where you might be asked to solve the angle too, like find the angle of depression, or find... That's what's it called.
Is that 100?
Find the angle at which the ship took off from the dock, something like that. Okay. But there's still going to be some tied into where you have to solve for certain sides. In general, when we are doing applications with right triangles, a lot of the times we draw a picture and we label it. I don't know if you're familiar with this notation, but this is important because I remember when I taught these problems in Algebra 2, I never told them this is how triangles are normally labeled. I just kind of expected they knew this. So I'm curious if you guys know this. So usually when we just have a right triangle in general, we use capital letters to notate the angles, and we usually use a capital C to represent the right angle in a right triangle. And then A and B doesn't really matter. I put A down here and B here. Maybe do this in geometry. Obviously, we haven't got to right triangle trig yet, but and then the sides across from these angles, we use the same letters, but lowercase. So this is where pi thing comes from. So a squared plus b squared equals c squared. Lowercase c usually denotes our hypotenuse. And then lowercase a would be this side across from A. And lowercase b would be the side across from B. Is that what kind of familiar of how you label triangles?
Yeah, I think so.
This is just pretty customary, like your textbook says. Not always. I mean, if I'm doing a word problem where I'm trying to find the height of a building, I often call it H. So we're just gonna do a couple problems where they ask us to solve a right triangle, and they give us A, B, and C ratios. Or I should say ratios. Angles or ratios if we're talking about side lines. But if you're asked to solve a right triangle, what that means is you have to find all the unknown sides and all the angles, both. Okay, if it says solve this triangle, anything that's unknown, you have to find. Angles and sides included. Okay, let's try one. So this one, they gave us a picture labeled exactly like how we just broke down that right triangle. There's something like this on your homework. It says solve this right triangle if angle A is 34.2 degrees and side B is 19.4. So I like to set up a little template of what I have to find. That means I have to find angle B. You didn't fix this.
Well, I never said I fixed it. Just look at how broken it was.
Okay, I need to find angle B. You don't need to find angle C. It's denoted as a right angle. I need to find side A, and I need to find side C. So I like to just set up a little template of what I need to find. Now, the fun thing about these problems is there's different ways to go about it. I was going to start with the easiest one. So, for example, angle B would be really easy to find. because how many total degrees are there in a triangle?
180.
180. Nice geometry skills. And we already know one of them is 90. So angle B is going to be, I mean, you can do 180 minus 90 minus, but just do 90 minus 34.2 degrees, which gives us 55.8 degrees. Yes, label it degrees. You probably do these problems in geometry, honestly. Okay, now let me give you some advice. As I mentioned, there's a lot of different ways you can go about this, but err on the side of using the information given to you. So for example, if I want to find side A next, I want to use the 34.2 and I want to use the 19.4 in case I made some mistakes in my work. So with what's given to me, I want to find the opposite side and I know the adjacent side. So which trig function would I use there? Tangent, yep. Tangent of 34.2 degrees is opposite over adjacent. Okay, we've done ones like this. Multiply both sides by 19.4. Unless it specifies round to the 4. Well, don't even round. Take the first 4 and do dot, dot, dot. Does it make sense? Oh, we are literally talking about this in geometry right now. Does it make sense that side A is shorter than side B?
Yeah.
Why?
The angle small?
It's across from the smaller angle. Yep. It's called the hinge theorem. Remember that?
No, but, you know,
Actually, it's not really the hinge theorem. I shouldn't say that.
something stuff, I guess.
Kind of the hinge theorem. Okay. To find C, a lot of options. We could use Pythag, and I'm okay with you doing that. But again, I like to err on the side of using what's given for me. So I'd probably set up another trig function. I would probably say, okay, now I want to find the hypotenuse and I know the adjacent, so I'd probably use cosine. Cosine of 34.2 degrees is adjacent 19.4 over the hypotenuse, which is C, times both sides by C. And then again, we're only using given numbers to us, so I don't have to worry about in case I made a little calculator mistake in using that in my next answer. Okay, so for this side, I got 23. And of course, our hypotenuse should always be the longest side. So here's my answers. Oops, this one don't work. If you do use a previous answer, use the exact number in your calculator. Okay, so let's say you did use that 19.4. Ooh, I don't know if I'm in degree mode. Nope.
That wasn't bad.
Can you go to the bathroom real quick?
Yes.
Nope. Have fun, don't get lost.
Sometimes it does my finger as like an eraser. 19.4. If you did use this, I just want to quick show you.
Would that make it exponent?
What did I do? Like if you're doing Pythag, use like that full like answer. So you would do like that whole entire decimal, like feed that in. You want to square that and don't like use the rounded. Okay, that's how you're gonna get exact. That plus the b squared. Oh my gosh, this is way too annoying. It's been really good recently. How does your answer? Second, and then the negative sign. ANS is right above it.
Second answer.
Okay, and then you can square root that. You'll notice we get the same answer. But again, I always kind of err on the side of using the information given to you. All right, next one. Ooh, an isosceles triangle. Isosceles triangle means how many congruent sides? 2. And if these are the congruent angles, which would be the congruent sides?
2 on top right.
Yeah, the opposite ones. Good. Good old geometry.
The opposite ones. Look at a different angle. 2 different opposite ones.
Okay, so we know the angle is 32 degrees. I'm going to go ahead and label that. And we know that B, the base here, is 8. What's an altitude? Anyone remember?
Height.
Yeah, the height. Yep.
Sorry.
Height is another way to think of it. Or from the vertex perpendicular to the other side is another way to think of it. I'm going to call it H. Okay, so as we mentioned, we know these are congruent. So in an isosceles triangle, the height is, or the altitude that goes from like the vertex, we call it the vertex angle, to the base, is always going to split the base like in half because of the congruent. Another way to think of that is if this were like a line, any point that is like equidistant from the line is like perpendicular. And like these would be equidistant too. Or like goes through the midpoint. You can think of it that way too. You do like all that discovery in geometry. Okay, so basically, what are we trying to find? H. We know this is 4 then. So I could set up.
2 right triangles.
We don't even have to do 2. We can just do 1 here. Like let's just say we could do this one.
These 2 right triangles.
We could do the tangent of 32 degrees would be my height over 4. My height, my altitude.
Bless you.
Thank you.
God bless you.
Thank you. 4 times the tangent of 32 degrees. Oh, I see degrees. Make sure you're in degree mode. I got about 2.4944. Probably should put units since we're talking about a height or an altitude. Okay. What a good little geometry review.
Yo, so great.
Now we're just going to do a couple application problems. We'll start off easy with like ones we're finding the side, and then we'll kind of get a little bit harder. Okay. We've done ones like this before. A safety regulation states that the maximum angle of elevation for a rescue ladder on a fire truck is 72 degrees. A fire department's longest ladder is 110 feet. To the nearest foot, oops, I didn't do that. To the nearest foot, what is the maximum safe rescue height? Okay. Here's my fire truck. Here's my building. Draw the ladder. All right, so we know the angle of elevation is the angle parallel to the ground with the line of sight looking up at something. So be this angle. Be my angle of elevation. Oh, we know that. It's 72. Let's label that. 72 degrees. We know the ladder is 110 feet. And we are trying to find the maximum height of the safe rescue height. Which trig function would I use here? Sine. Someone say sin.
I almost have sin.
As a joke.
Sure.
Opposite over hypotenuse. Again, make sure you're in degree mode. Okay, I didn't round this to the nearest foot, but I will now. We got like 104.6162, so 105 feet. I know, right? That's kind of what I was thinking. I was like, oh, I probably should round down. We don't want to overestimate our maximum safe rescue height. Okay, step it up a notch.
No, I don't think you should.
At a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees, whereas the angle of elevation to the top is 53 degrees. Find the height S of the smokestack alone. Do you guys know what a smokestack is? Oh, thank you. It's basically like, it's kind of like a chimney of like factories. So like something that the smoke comes out and they kind of like look like that. It doesn't have to be perfect. All right, so they said at a point 200 feet from the base of the building, the angle of elevation to the bottom of the smokestack is 35 degrees. So angle of elevation is the line parallel to the ground to the line of sight looking up. Whereas the angle of elevation to the top is 53 degrees. That whole angle is 53 degrees. Find the height S of just the smokestack. Just that piece right there. Okay, so we're gonna have to kind of set up some, a couple ratios here. This is kind of like that mountain one we did before. Let's do this little right triangle first. So I see two right triangles here. I have this one where I know this angle is 35 degrees. I don't know this. I'm going to just call it A. You can call it X. You can call it H. You can call it whatever you want. But I know that the tangent of 35 degrees would be that height, that A value, over 200 feet, opposite over adjacent. So I can figure out what that A value is by taking 200 times the tangent of 35 degrees. I'm going to leave it as this long number because I want exact answers. Obviously, you can type that in your calculator and get an approximation to give yourself like a little contextual understanding, but I'm going to leave it like that. Okay, then I have this bigger triangle here. Still a right triangle. Where my angle of elevation is 53 degrees. I can take the tangent of 53 degrees. What would my opposite side be in this case? Of this triangle, what would my opposite side be? A plus S, good, or S plus A, doesn't matter. A plus S, good. Over 200. Okay, so times those sides by 200. And we know what A is, and we're trying to solve for S, so I'm going to solve this equation for S. I can take the 200 times the tangent of 53 degrees minus A. We know what A is. So again, I want to leave it in that exact form. So in my calculator, I can just type this all in at once. I can do 200 times the tangent of 53 degrees minus 200 times the tangent of 35 degrees. I'm trying to solve for S. Okay, let's try it. Tangent of 53 degrees. Make sure you close that. Minus 200 times the tangent of the 35. Still in degree mode, so we're all good. Looks like we are measuring distance in feet, since that's what my distance from the building. So 125.3674 feet. Now, sometimes the ones on your homework like come with a picture. I think I stole this one from the textbook and it included the picture, but sometimes it's good practice to draw your own picture too. And some of them you don't get a picture. Okay, you guys try the next one. It's very similar. You guys try this one. And I gave you the picture this time. A passenger in an airplane at an altitude of 10 kilometers sees two towns directly to the east of the plane. The angles of depression to the towns are 28 degrees and 55 degrees as shown. Remember, angle of depression is from a line parallel to the ground to the line sight down. So 28 to the further town, 55 to the closer town. How far apart are the towns? You gotta find this distance. Okay, let's try. Give it a whirl. Very similar to the last one we just did. And maybe we'll stop at this one. Just for sake of time, I'm gonna start writing out my work, but keep working. Okay, you guys done? You do right triangle applications in geometry.
Yeah.
You just haven't had that part on this. You do them in algebra too. Do you remember doing this last year?
Really?
Not what if we did.
I do a little bit of figuring with those angles there to form the right triangles. You probably also could have like made right triangles like this way. You could have done that. Did anybody try that? What would my units be here? Okay. Did we get that answer? So I'll finish these up tomorrow. I think we only have like 3 more problems to do. But I will get started on your bookwork for 4-7, definitely. 4-8 as well. And we'll finish it up tomorrow.
What was the answer?
11.8.
Look at that.
You got it?
Yeah,
Get it, Ashton.
I never got it.
Better pause the recording. I'll save those notes for later.
How are you?